We are one step closer to unlimited power. Scientists from California's Lawrence Livermore National Laboratory set to announce a major breakthrough in so-called fusion energy. In other words, it's a BFD. Fusion energy does not emit any carbon, does not produce any radioactive waste. So what does that mean for the you and the me? Joining me in studio, astrophysicist at the American Museum of Natural History. He's the author of Starry Messenger, Cosmic Perspectives on Civilization, a phenomenal book, A Wonderful Man. Neil deGrasse Tyson returns.
Thanks for having me back.
Oh yeah, this is so exciting. I mean, I love your book. We did a wonderful podcast about it.
Yes, we did.
And you illuminated some of the more interesting aspects of your life and culture and your view on such from a global perspective, galactic perspective. But now,
a cosmic perspective.
Absolutely right. But we may be able to harness the power of at least our star. So what does this fusion discovery mean for
Many
us?
people, when they think of nuclear energy, they think of nuclear fission, which was the energy source in the two bombs used in the Second World War. Very quickly after that, we magnified the energy of those bombs by creating a whole other kind of bomb, which came to be known as hydrogen bombs. The hydrogen bombs don't have the radioactive baggage that fission bombs do. Hydrogen bombs are fusion. So fission, let's back up. Fission, you take a big atom, break it, and you weigh those two atoms, and they weigh less than what you started with. Where did the mass go? E equals mc squared. The mass went to energy. You can do the same thing, but coming from the other direction. You take a very light atom, hydrogen, fuse it together with another hydrogen atom, and you get helium. And your product has less mass than you started with. Once again, you get energy, but you don't have all of the byproducts. We've made fusion for 60 years. The problem was we don't have controlled fusion, and when we don't have controlled fusion, it's called a bomb. But when you control it, then you can throttle it, you can valve it, you can put it where you need to and how you want to use it. And so right at this moment, I don't think people know for sure what the announcement will be. But if the Secretary of Energy is giving the press conference, everyone I think is thinking that we finally can get out more energy than we put in, and that is the...
Oh, and that has been the key, because for so long we've been trying for decades.
It's been the holy grail, and I thought we would have reached that in the 80s,
yes,
but then we didn't. Maybe it's because peace broke out in Europe and people took less interest in what physicists could do.
Yes, and we had a different type of nuclear energy for quite some time.
Well, that's right, that's right. No, but there was physics labs still working on this. Here's the problem. In order to have fusion, you need very hot plasma, which is like an ionized gas. So hot that it can't touch anything that might contain it. If I give you plasma and put it in a suitcase, the suitcase would vaporize. So one of the great problems is the containment of such very high temperature gas. And because the gas is like ionized, which means there are free electrons moving around, you can contain it in a magnetic vessel, a magnetic bottle, a magnetic shape, so that it tries to escape it, but it can't, because it's charged and it repels the magnetic field. These are the challenges that the physicists faced for decades.
All right, so let's say we've overcome some of those challenges and finally created more energy than we put into the experiment.
That's it.
So when do we get fusion stations? When do I get to plug my car in the fusionorium?
So now it's up to the engineers.
Okay.
Once we get the physics figured out, which it seems like we have, then the engineers say, can I make that smaller? Can I make it portable? Would it fit in a car? Or is it only the size that might power a city? There are places that don't have access to energy, either oil or even sunlight, for example, and so, or tidal or hydro. So this would be transformative to civilization. And I see it akin to the transition from horses to automobiles.
Yes.
Which happened in a matter of a couple of years because we got the physics figured out for engines and internal combustion engines. And when that happened, you couldn't give away a horse, yet we were riding horses for thousands of years, building civilization literally and figuratively on its back. So my analogy to that is, we've been digging fossil fuels out of the ground for 150 years.
How long will it take to heal the planet from any harm that we have done to ourselves?
Yeah, because here we are, like
carbon emissions,
harming a planet that itself was trying to sustain us.
Yeah.
That's not a. By doing that, you've sown the seeds of your own extinction, and so the planet will heal slowly. Yes. A lot of the carbon is up took into the oceans. So if you start dropping the carbon in the atmosphere, the oceans will equilibrate with that. So it'll take time. But now is better than any time later than now. So, oh yeah, I'm giddy.
I can't wait. I can't wait for my fusion engine.
It's a pivot. It's a pivot in civilization.
I'm sick of all these gassy dictators running things and ruining people's lives.
Right.
I want I don't mind a level playing field because I know that beautiful innovations in capitalism will follow when people have the energy.
Yes, of course. And
to fuel their ideas.
there's a whole chapter in that book on exploration and discovery, where I chronicle the pace of discovery that you don't see coming, came over here and over there.
There's also a great chapter on hair removal, which you don't see coming, but it is in there. It is a gift from the cosmos.
I do talk about that.
You do. Starry Messenger, Neil deGrasse Tyson, thank you so much for coming by.
Thanks for having me.
Always good to talk to you. Love your passion.